Good afternoon, good evening to everybody. I want to introduce our teacher. She is our teacher. Maybe for you it is new. Nivedita, and she is based in Bangalore now. Earlier she was in Coimbatore, and she is handling our NEET chemistry class for almost 2 years, madam.
Yes, sir. Yes.
Yeah, almost 2 years, and she is one of our big support for all of us. So now I request her to take on the class. Yeah. Yes, madam.
Okay, sir. Okay. Thank you, sir. Good evening, everyone. Good evening, guys.
Good evening.
Good evening, teacher.
Kana, in our chemistry session, we're going to learn concepts in chemistry and we're going to understand the subject better. Okay. Because as far as entrance exams are concerned, they'll test our fundamentals. So being strong in fundamental is very, very important. So in our foundation course, we'll be concentrating only on the fundamentals. Okay. Is that clear?
Yes, ma'am.
Okay. So before getting into the session, I would like to tell you something. Please, I want you guys to be more interactive. Only being interactive, the session will be interesting. Okay. Okay. You'll be interactive now? Abhinav?
Yes, ma'am. Yes,
Okay,
teacher.
Patel. Okay,
Yes,
Patel.
ma'am.
Okay, fine. So basically, I'm a chemistry teacher. What you guys know about chemistry? What is chemistry basically? I'm not expecting any right answer. I'm just expecting an answer. That's it. What is chemistry?
माहितीच नाही काय केमिस्ट्री सब्जेक्ट काय अजून आलाच नाहीये 9th पासून आहे तो मे बी
Kana, Kana, I don't understand. Can you please speak in English? What is chemistry? Abhinav?
I think it's something to do with all the formulas and equations,
Okay,
basically.
fine. Okay. Swastik, in your point of view, what is chemistry?
Ma'am, learning about chemicals, reactions.
Very good. Okay. Learning about chemicals and reactions. Superb. Okay. Fine. So in this session, we're going to understand few terms like matter, atom, molecule, elements, compounds, and very importantly, what is chemistry. Okay. So after understanding all those terms, we'll get into the concepts. Okay. Most of the terms were definitely those terms will be familiar to you. So we're going to have a quick recap of all those terms and then we'll get into the fundamentals. Okay. Fine. So, to understand chemistry, to understand what is chemistry, first of all, we have to understand few terms like matter, stability, atoms, molecules, and all that. Okay. So, we'll go one by one. First, what is matter? Let us forget about chemistry. Okay. Let us start from a scratch. What is matter? Again, not. Yes, Rakshan.
Anything that has mass and occupies space.
Very good, very good. The substance or anything which occupies some space and which got its own mass is called matter. Can you please give me some example? Rakshan was right. Substance or anything which occupies some space and which got its own mass is called matter. For example, I have. Yes.
Example for solid ice, liquid water, gas steam.
Okay, very good, fine. Can you please bit more specific? You told me eyes, okay? That is a perfect example for matter. Any other example for matter? How about Sachin Patel? Patel, yes. Your answer is right, Rakshan.
all of you can interact because this is madam is generally will have interactive session. Swastik, Srinidhi, everybody can open your mic and then talk. Okay.
Yes, sir.
Okay. For example, I have a pen. Okay. Pen will occupy some space, right? Pen will have its own mass. So I can call this pen a matter, right? Pen is a matter, right?
Yes,
Yes,
ma'am.
Yes, ma'am.
I have a notebook. Okay. Notebook will have its own mass and notebook will occupy some space. So notebook is a matter, right?
Yes,
Yes.
As
ma'am.
Rakshan said, he told ice cube is a matter. Is that right?
yes,
It
ma'am.
was perfect because ice cube will have its own mass and ice cube definitely will occupy some space. So ice cube is a matter, right? I have a bottle full of water. Water will occupy some space and water will have its own mass. So water is a matter. The air, what we are breathing in, air will have its mass and definitely air will occupy some space in this universe. So air is a matter, which means everything around us is a matter. Even we are matter, right? Because we are occupying some space in this universe and we got our own mass. So definitely everything in this universe is a matter, right? Okay.
Yes, ma'am.
And this matter can exist in three different forms. That is what Rakshan told us, right? What are all those three different forms?
Solid, liquid, and gas.
Very good. Solid, liquid, and gas. What is the basic difference between solid, liquid, and gas? So we understood what is matter, and we know now there are three physical states for matter. One is solid, liquid, and gas. I'm asking what is the basic difference between solid, liquid, and gas?
Ma'am, solids are matter, I mean, stuff which are tightly, I mean, in which the molecules are tightly packed.
Very good. Okay.
And water, I mean, liquid, it is somewhat less, I mean, the intermolecular space is less than that of solid. And in gas, it's free to move, like the space is very more.
Yes, Abhinav was right. Fine. So, matter can exist in three different forms: solid, liquid, and gas. And the basic arrangement will be different for solid, liquid, and gas. Okay, but before getting into those arrangements, we have to understand another two terms. One is atom, and another one is molecule. Abhinav told me if the molecules are closely packed, then that is in solid state. If that is quite loosely packed, then that will be liquid. If the molecules are free to move, then that is called gas. But before getting into that arrangement, we have to understand what is atom and what is molecule. Okay. So, but before getting into that, now we understood what is matter, right? Matter is something which occupies some space and which got its own mass is called matter, right? Now we're going to understand what is atom and what is molecule. After which we can understand the physical states, okay? Fine. I have a compound wall. Okay. Compound walls are made up of what? Compound walls are made up of what?
Bricks, cement.
Bricks, right. Without bricks, will the compound wall will exist?
No, ma'am.
No. So bricks are the basic building block of that compound wall. Similarly, all the matters are made up of a building block called atoms. So atoms are the basic building block of all the matters in the universe. So without atom, these matter cannot exist. So basically, without bricks, compound wall cannot exist. No. Similarly, without atoms, matter cannot exist. So atoms are the basic building block of all the matters in the universe. Okay, atoms are fine. But what is another term called molecule? So atoms are the basic building block, but what is molecule?
A group of atoms.
Very good. Group of atoms are called molecule. Okay. Why atom has to be in group? Why atom has to combine with another atom to form a molecule?
Ma'am, as atoms cannot stay independently.
Very good. Why so?
Ma'am, they're always reactive. That is, they react with some other metals.
Super.
Sorry. Yes, ma'am.
Yes, very good, very good. So atoms are reactive. Atoms cannot stay alone. Everything is fine. But why? Why atoms are reactive? Why atoms cannot stay alone? I'm expecting a term. Okay, now we'll understand. Okay. So basically, atoms are single entity, but this atom cannot exist individually. One atom has to combine with another atom to attain stability. The term stability is very, very important in chemistry. Okay. What is stability? What is stability? It is a state where we can stay for a very longer time is called stability. Okay. Or we can call it as a comfort zone. See, for example, I'm going to give you two scenarios. Okay. Tell me where you'll be very comfortable. Okay. First scenario is in your home. Another scenario in your school where you'll be very comfortable, where you can stay for a very longer time in your home or in school.
I'm in home.
Okay, so super. So in home, you'll be very happy. Home is your comfort zone. So that is the place where you're more stable, right? So for us, comfort zone is very important. For us, happiness is very important. Similarly, for atom, happiness is important. For atom, comfort zone is important. But this comfort zone is technically called as stability. Okay. Atom as such is unstable. Atom cannot exist as atom for a very longer time. Atom has to combine with another atom to feel comfortable or to feel its stability. So atom has to combine with another atom. See, without friends, we'll be feeling very lonely, right? Right? Without friends, you'll be happy?
No, ma'am.
Definitely not. Definitely, we need friends. Without friends, we'll be feeling very, very lonely. Similarly, atoms also need friends to attain its stability. So, atom has to combine with another atom to attain its stability. Right? Okay, I'm going to give you a question. See, there are few atoms which will not combine with another atom. Do you know which atom is that? Atom will not combine with another atom to form a molecule. There are few atoms in the periodic table. Do you know which atoms will not combine with another atom? Okay, can you please give me some examples for atom?
Ma'am, hydrogen, oxygen.
Very good. Very good. Hydrogen, oxygen, then?
Helium, lithium.
Very good. Helium, lithium. Okay. We have so many atoms, right? We have 118 types of atoms in the periodic table. So you gave me only 4 examples. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, all these were atoms, right? Okay. In these 118 types of atoms, few atoms will not get converted into molecule at all. Can you please tell me which are those atoms? Helium, neon,
Argon.
very good. Helium, neon, argon, krypton, xenon, radon. these atoms will not combine with another atom because atom as such is stable. These atoms without getting converted into molecule, they are stable. Okay. So these atoms are called noble gases or inert gases. Why they are called inert gases? What does mean by inert? These atoms are non-reactive. These atoms will not get involved in any chemical reaction. Okay, that is called inert. Okay, fine. So we understood what is matter and we understood atoms are the basic building block of any matter, and we understood atoms cannot exist individually because atom as such is unstable. Atom has to combine with another atom to attain its stability. So I have an atom A, it is unstable. Okay, I have another atom B which is unstable. So this atom has to combine with this atom. So for combining, there should be an attraction, right? Technically, what is attraction called? The attraction between two atoms are called? Between two students, there should be a friendship, right? Without friendship, they cannot stay for a very longer time together, right? Similarly, between two atoms, there should be a force of attraction like friendship, that is called chemical bond. Okay, so two atom has to combine together through a force of attraction called chemical bond. So if there is a chemical bond between two atoms, then these two atoms will exist together, and together this system is called molecule. Now these two atoms are more stable. Okay, so we understood atoms and we have seen few examples of atom, and we also understood atom as such is unstable. Atom has to combine with another one to attain its stability. So the attraction between two atoms are called chemical bond. So a group of atoms are called as molecule. Okay, can you please give me few examples for molecule? Few examples for molecule.
Carbon dioxide.
Very good, carbon dioxide. Swastik, can you please give me the formula of carbon dioxide?
CO2.
Very good, CO2, in which one carbon is combined with two oxygen atoms. Super. Okay. Another example.
Oxygen and ozone.
Very good. But I want the formula.
O2, O3.
Very good. O2, O3. Among this, which is ozone?
O3.
O3. Very good. Rakshan, can you, what is your name? Is it Rakshan?
Yes, ma'am.
Okay, fine. Which class you are in?
9th, ma'am.
9th standard. Super. Okay. How about ammonia? Ammonia is a molecule or atom?
Molecule.
Molecule. What is the formula of ammonia?
NH3.
NH3. Super.
Water.
Very good. Water. What is the formula of water?
H2O.
H2O. Super. I'm going to write a molecule. Please tell me the name, okay? CH4. Yes, Abhinav.
Actually, I'm not sure about CH4. CH4.
Methane.
Very good, Swastik. It is methane. Okay, so CH4 is called methane. Okay, I'm going to write another complicated molecule. Please try, okay? What is this? CH4 is methane. Yes, Swastik?
Ethane or ethene?
It is ethane. Okay. So this is called ethane. Super. And this is called methane. So all these were molecules. Okay. So now we understood what is matter. what is atom and what is molecule, and why atom has to why atom has to get converted into molecule. Why atom has to get converted into molecule? To attain its stability. Atom as such is unstable, but there are few atoms which was stable in its individual state. Which are those atoms? Which are those atoms?
Hydrogen,
No,
neon,
no. Helium,
uh,
neon.
helium, neon, krypton,
Very good, very good. Yes, Srinidhi, yes. Helium, neon, argon, krypton, xenon, and radon. Okay. So all these gases are called
Noble gases or inert gases?
very good noble gases or inert gases. Why they are called as inert? Because
They
yes,
don't
Abhay,
react.
they don't get involved in chemical reaction. Super. Okay. There is a force of attraction between two atoms. What it is called? The force of attraction between two atoms.
chemical bonding.
Very good. Chemical bond. Super. Okay. Now we understood atom, molecule, matter, chemical bond, stability, and all that. Okay. Now we're going to understand what is element and compound. Okay. Guys, please tell me what is element and what is compound.
Element is the free state of the atom and compound is the combined state.
Kind of. Kind of, yes.
Yes.
Can you please give me some example for compounds, Vastik?
Compounds, NaCl. ma'am.
Okay. NaCl is a compound, true.
Yes, ma'am.
But NaCl is not a molecule.
Their molecule also. ma'am.
Okay, so they're molecule and compound, right?
Yes, ma'am.
Okay, fine. Is there any other example for compound?
Ammonia.
Yes, ammonia is a compound, yes, sir. But here, ammonia I've written the example of molecules, right? So, what is the difference between molecule and compound?
Molecule will have same elements. Compound will have different elements.
Okay, sir. Okay, fine. Rakshan, do you know what is the difference between molecule and compound? Okay. We know
Two or
what is
more elements together form compound. Single element forms molecule. I mean, an element.
element. Okay, fine. See, I'm going to take a matter. Okay. What is matter? This got its own mass and this will occupy some space, right? So, if this matter is made up of only one type of atom, for example, I'm going to take this atom. What is this? What is this?
Sodium.
Very good. This is sodium. So sodium is a atom, right? So this is my matter, and this matter is made up of only one type of atom. Then this matter is called element. Okay. I'm going to take a diamond. Okay. Diamond is a matter, right? Diamond stone. Diamond stone is a matter, right?
Yes, ma'am.
Okay. So diamond stone is a matter. Okay. This diamond stone is made up of only carbon atom. So diamond is it's an element, right?
Yes, ma'am.
I'm going to take a copper wire. Wire is a matter, right? Because wire will occupy some space and wire got its own mass. So wire is a matter, and this wire is made up of only copper atom. Then this matter is called this wire is called an element. Right? You got my point?
Yes, ma'am.
So element is something, element is a matter which is made up of only one type of atom. Okay. Similarly, let us check for compounds. Okay. I have a beaker full of water. So water is a matter, right? And this matter is made up of same type of molecule. Then this matter is called compound. Okay. So if I take NH3, I'm taking only one individual NH3 molecule. So this is called molecule, right? Now I have a cylinder full of NH3. So the cylinder full of NH3 system got so many tons and tons of NH3 molecule. So this is called compound. Is that clear? Is that clear?
Yes, ma'am.
NaCl is a molecule because this molecule contains two atoms. One is sodium, another one is chlorine, right? I'm going to take a spoonful of sodium chloride. So this is a matter and this is made up of same type of molecule. So this is a compound. Is that clear? Is that clear?
Yes, ma'am.
Very good. Okay. So CH4 is a methane. This is a molecule because this contains one carbon and 4 hydrogen atoms. So group of atoms are called molecule. Now I have a cylinder full of CH4. So cylinder will have tons and tons of CH4 molecule. Now that system is called compound. Is that clear? So compound is nothing but it is a matter which is made up of same type of molecule, then that is called compound. Is that clear? Fine.
Yes, ma'am.
Now we understood what is matter, what is atom, what is molecule, and element and compound. Fine. Okay. Next, I'm going to write few examples. Now you're going to tell me which is atom and which is molecule. Okay. What is this? Is it atom or molecule?
Atom.
Atom. Very good. What is this?
Atom.
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 What is this?
Atom.
Atom.
What is the name of this atom?
Chlorine.
Chlorine. This is atom, and what is the name of this atom?
Calcium.
Calcium. Super. CO2 is a molecule, and this is called carbon dioxide. See, I'm going to write the structure of this carbon dioxide. Okay. Carbon is connected with 2 oxygen atoms. So, 2 oxygen atoms. What is this? What this line is called?
Bond.
It is called a chemical bond. Basically, there is a force of attraction between carbon and oxygen, and that force of attraction is represented by a line called chemical bond. So between carbon and oxygen, we have 2 chemical bonds. Okay. This is ammonia. Nitrogen is connected with 3 hydrogen atoms. Okay. Methane. Carbon is connected with 4 hydrogen atoms. What is this? This is methane, and what is this?
Ethane.
Very good, it is ethane. So I'm going to write the structure of ethane. You need not memorize all these structures, okay? In your 11th standard, definitely you'll write all the structure of all the inorganic molecules. Now you need not worry about structure. So carbon is connected with another carbon, and each carbon atom is connected with hydrogen atoms. Okay. Is it atom or molecule? N2. Is it atom or molecule?
Molecule.
Molecule. In this molecule, how many atoms are there?
2 atom.
Two. Two nitrogen atoms are connected together through triple bond. Okay, fine. See, here I've written so many molecules and their structures. Now we're going to count the number of chemical bonds. See, as far as carbon atom is concerned, in carbon dioxide molecule, around carbon atom, how many chemical bonds are there? 1, 2, 3, 4. So around carbon atom, how many chemical bonds are there? 4. Right? Okay. In methane molecule, around carbon atom, how many chemical bonds are there? In methane molecule, around carbon atom, how many chemical bonds are there?
4.
3.
Again, 4. 1, 2, 3, 4. Okay. In ethane molecule, around carbon atom, how many chemical bonds are there? As far as this carbon is concerned, 1, 2, 3, and 4. As far as this carbon is concerned, how many chemical bonds are there? Again 4, right? So though these are different molecule, in all the molecules carbon got only 4 chemical bonds. So that is the combining capacity of carbon. So carbon has to combine with another atoms to attain its stability, but the capacity is limited. Carbon can form only how many chemical bonds? Carbon can
4
form
chemical
only,
bonds.
very good. Carbon can form only 4 chemical bonds, and this is called combining capacity, or it is also called as valency. So what is the valency of carbon?
4.
Very good, very good. Okay, guys, now you tell me what is the valency of hydrogen? What is the valency of hydrogen? Very good. It is 1, because as far as ammonia is concerned, hydrogen got only 1 chemical bond. So each hydrogen got only 1 chemical bond in ammonia. As far as methane is concerned, each hydrogen got only 1 chemical bond. So what is the valency of hydrogen? It is 1. Is that clear? Is that clear?
Yes, ma'am.
Fine. What is the valency of nitrogen?
3.
Very good, it is 3. What is the valency of oxygen?
2.
2. Rakshan, is that clear?
Yes, ma'am.
Swastik?
Yes, ma'am.
Sriniti?
Yes, ma'am.
Okay. So this valency is called combining capacity. So atom definitely has to combine with another atom to attain its stability, but the combining capacity is relative to each atom. Carbon's combining capacity or valency is 4, hydrogen's combining capacity is 1, nitrogen's combining capacity is 3, and oxygen's combining capacity is 2. So in periodic table, each atom will have its own combining capacity or valency, and definitely we have to know about that. Okay. Now tell me, what is the valency of helium? What is the valency of helium? What is the valency of helium?
0, ma'am.
Very good, Swastik. Valency of helium is 0. Because helium will not combine with any other atom. So helium will not have any combining capacity. So the valency of helium is 0. How about neon?
0.
0. That's it. Is that clear?
Yes, ma'am.
Fine. Okay. Now we'll move on to another topic. See, I have A. It can be atom, or it can be molecule, or it can be cation, or it can be anion. It is just a chemical species. Chemical species is a common term. I can use it for any system. I can use it for atom. I can use that for molecule. I can use it for element. I can use it for compound. Chemical species is a common term. Okay. This chemical system or this chemical species as such is unstable. Okay. Will it be happy? Will this be happy? This is unstable. Will that be happy? No, definitely not. So, definitely this system will get converted into another stable system. Right? So, because as such this is unstable, so this will find a way to attain its stability. So, now this A is getting converted into a compound B. Fine. Now this is stable. So in this process, an unstable system is getting converted into a stable system. Right. This process is called process of conversion of unstable system into a stable system is called a process or a chemical reaction. So what is chemical reaction? It is a process where an unstable system is getting converted into a stable system, and this process is called a chemical reaction. Is that clear? Is that clear?
Yes,
So what is chemical reaction? It is a process of conversion of unstable system into a stable system. This is called chemical reaction. And studying about this chemical reactions are called chemistry. Is that clear?
Yes, ma'am.
Yes.
So, Swastik told me chemistry is a subject where we'll be studying about chemical reaction. He was right. But what is chemical reaction? It is a process of conversion of unstable system into a stable system. Okay, being stable is very, very important. Okay, any unstable system will find a way to get converted into a stable system. Okay, being stable is very, very important. Fine. So that is called chemical reaction, and studying about this chemical reaction is called chemistry. Fine. So now what we understood till now, we understood what is atom, what is molecule, what is element, compound, matter, chemical bond, and what is chemistry. And we also understood about valency. Okay. Now we'll analyze this atom. Okay. Atom is the basic building block of all the matters in this universe. Fine. Atoms are made up of what? Is there any other particle which is present inside the atom? Matters are made up of atom, but
Particles.
come again, Abhinav?
Subatomic particles.
Yes. Subatomic particles are nothing but the particles which are present inside the atom. Okay. What are all the subatomic particles you're talking about?
Proton, electron, and neutron.
Very good, Rakshan. So, atom contains subatomic particles called proton, neutron, and electron. Okay. So, these are the particles which are present inside the atom. Among these particles, which got charge and which doesn't have charge?
Neutron doesn't have charge.
Neutron.
Neutron does not have any charge. What is the charge of proton?
Positive charge.
Very good, very good. Positive charge. And what is the charge of electron?
Negative charge.
Negative charge. Super. Okay. So, now tell me, what is the charge of atom?
Neutral.
Very good. Why? How it is neutral? Atom
It is
contains
only-
positive. Atom contains positively charged proton, negatively charged electron. But how atoms will be neutral?
There are equal number of protons and neutrons, so
Very good.
plus and minus gets like neutral.
Yes. So every atom will have equal number of protons and electrons. So neutral is nothing but a positive charge will be there, negative charge will be there, but they'll be in equal numbers. So atoms are basically a neutral species. Is that clear? Okay. Now I have another question. You told me about the charge. I want to know about the mass. What is the mass of electron and what is the mass of proton and neutron? I remember you guys telling these mass in some other foundation class. I've seen that. What is the mass of electron?
Ma'am, 1.7 into 10 power minus 17 something.
Okay. That is kind of charge. 1.6 into 10 power minus 19 coulomb.
Okay, ma'am.
Okay, what will be the unit of mass?
Nanometer.
Unit of mass. You're telling me in terms of meter. Meter is a unit of length, right?
Sorry, nanogram.
In terms of gram. Okay, it is gram. That's it.
Okay.
Okay, I'll tell you the masses of all these subatomic particles. Okay.
Ma'am, mass of proton is 1.67 into 10 to the power minus 7, minus 27. And the
Unit
mass
is
of,
very important. You're right, Rakshan. But unit is very important. See, mass of neutron is 1.6 into 10 power minus 27 kilogram. Right? What is the mass of electron? What is the mass of
9.1 into 10 to the power minus 31 kilogram.
Very good in terms of kilogram. Super. So mass of neutron is 1.6 into 10 power minus 27 kilogram and mass of electron is 9.1 into 10 power minus 31 kilogram. And mass of proton is similar to neutron. It is again 1.6 into 10 power minus 27 kilogram. Now I want to know among these three subatomic particles, which is the lightest one? Which is the lightest one?
Electron.
Electron. Very good. So among these subatomic particles, electrons are considered to be the lightest one. Very good. Okay. Now we'll talk about the charge, okay? You told me the charge of proton is positive and the charge of the electron is negative. Now I want to know the quantity of the charge. You told me it is plus and you told me it is minus, but I want to know the quantity or the magnitude of the charge. How much positive and how much negative these protons and electrons are. In fact, now I told that value. Charge of electron is 1.6 into 10 power minus 19. And what is the unit of charge?
Coulomb.
Coulomb. And what is the symbol of Coulomb?
C.
C. Capital C. Okay. So since electrons are negative, this is minus 1.6 into 10 power minus 19 Coulomb. How about proton? The quantity is same, but the sign is different. 1.6 into 10 power minus 19 Coulomb. And there is no charge for neutron. Is that clear? Is that clear?
Yes, ma'am.
Fine. Okay. So now we are talking about these units, no? Do you know how to convert, do you know these unit conversions and all? Unit conversions? Okay, now we'll understand or how we'll learn how to convert one unit to another. Okay, after which we will again continue about this atomic structure. Fine. Shall we move on to unit conversion?
Yes, ma'am.
After understanding the unit conversion, we'll come back to this atomic structure and we'll understand what is atomic number, what is mass number, how to find proton count, or how to find electron count and all. Okay. Okay. Before getting into this unit conversion, we have to know few numbers and those prefixes. We'll understand that. Swastik, you told me some nano, no? What does that nano mean? You told me nanometer, nanogram and all. What is that nano?
That is subdivision of that. For example, meter, kilometer, like that we'll say.
Okay. Similar to nano, you know anything else?
No, ma'am.
Okay. See, guys, listen. For a quantity or for any number, we'll be giving a prefix. For example, 10. Okay, this is 0.1. This is a number, right? The 0.1 can be written as 10 power minus 1, right? Both are same, right? 0.1 and 10 power minus 1 are same, right?
Yes, ma'am.
Patel, they are similar, right? 0.1 and 10 power minus 1 are same, right? How they are
Yes.
same? How they are same? 0.1 is nothing but 1 by 10. Okay, here the power of 10 is plus 1. I'm going to take this number to the numerator. So this is 10 power. If you are taking this number to the numerator, the sign of power will get changed. Here this is plus 1, this is minus 1 now. So 0.1 is equal to 10 power minus 1. So for this number, I can give a prefix called deci. Okay. Similarly, 0.01 can be written as in terms of 10. How I can write the 0.01 in terms of 10?
10 to the power minus 2.
Very good. 10 power minus 2. And the prefix what I'm going to use here is centi. What is prefix? What is prefix? It is the term what we going to use at the front of the word. For example, Swastik told me a nanometer. So meter is a word or meter is the unit. Before this meter or before this word, I'm going to use a term called prefix. So it can be decimeter, it can be centimeter, it can be millimeter, it can be micrometer, or it can be nanometer. Okay. So the term what we are using at the last part of the name is called suffix. Okay. Prefix and suffix are two different terms. Fine. Similarly, 0.001 can be written as 10 power minus 3. And what is the prefix for 10 power minus 3? Prefix for 10 power minus 3 is?
Milli.
Very famous. Very good. It is milli. So all these prefixes, we have a symbol. Small d, small c, small m. Okay. Similarly, for 10 power minus 6, we have a prefix called micro. And the symbol of micro is this. The symbol is called mu. Mu. Okay. And 10 power minus 9, the prefix is swastik. The prefix is nano.
Yes.
Okay. And what is the symbol of nano? Very easy. What is the prefix of milli? It is m. What is what is the symbol of centi? It is c. What is the symbol of deci? It is d. So what is the symbol of nano?
N.
N, that's it. Small n, that's it. Similarly, 10 power minus 10, it is called angstrom. 10 power minus 2, it is called pico. And the symbol is small p. 10 power minus 15 is femto. It is called, the symbol is F. Okay. Similarly, 10 power 3. Just compare 10 power minus 3 and 10 power plus 3, which is a smaller and which is bigger one.
10 to the power 3 is
10
bigger.
power plus 3 is bigger one.
Yes, because 10 power 3 is nothing but 1000. 10 power minus 3 is nothing but 0.001. So this is a bigger quantity, and the prefix of this 1000 or 10 power 3 is very famous term.
Kilo.
Kilo. Very good. Kilo. And what is the symbol of kilo? Symbol is very important.
Capital K.
K.
Okay. Rakshan is telling me it is K. Abhinav is telling me it is capital K. What should I write right now?
Capital K.
Okay. It is not kg. Okay. Most of the student told me it is capital K, right? Is it capital K or small k?
Capital K.
Okay. For the symbol of kilo is small k. It is not capital K. See, in our regular life, for 1000, we'll be replacing it with capital K. But in science, 1000 has to be represented with a small k. Whenever you're writing capital K in science, that represents Kelvin and not kilo. Okay. So whenever you're writing kilo, please use small k and not capital K. Is that clear?
Yes, ma'am.
Fine. Similarly, for 10 power 6, the prefix is mega and the symbol is capital M. For 10 power 9, the prefix is giga and the symbol is capital G. That's it. So you have to know all those numbers and those prefixes with symbol. Fine. Now we'll understand how to do a unit conversion. Shall we move on to unit conversion? Fine. Till now, you guys have any doubt? Please ask me.
No, ma'am.
Okay. Now we'll do a unit conversion. Most of the students will be familiar with unit conversion. If you are familiar, we'll revise. If you don't know, we'll learn now. See, I'm going to have a number 54 millimeter. Okay, so this is a quantity which we are giving to a length, right? Because I'm expressing that for that in terms of meter. Meter is a unit for length, right? Okay. 54 millimeter. Now I have to convert this millimeter into nanometer. Shall we convert this? Okay, to convert this, I'm going to give you a couple of steps. Please follow that. By following that, we can convert one unit into another unit without making any mistake. Okay, please concentrate here. So the first step is 54. What is the quantity of milli? What is the quantity of milli? 10 power minus 3. So 54 into 10 power minus 3 meter. So this is the first step. The second step is I have to convert millimeter to
Nanometer.
Nanometer. So 54 into 10 power minus 3, and I'm going to write the unit to which I'm going to convert, nanometer, divided by what is the unit, what is the quantity of nano? What is the quantity of nano? Ten power?
Minus 9.
Minus 9, that's it. So bring this 10 power minus 9 to numerator. Simplify those numbers. 54 into 10 power minus 3 into 10 power Now I'm bringing this 10 power minus 9 to numerator. So what will be the value? 10 power
Plus 9.
plus 9 nanometer. Now simplify these two terms. 54 into, we have common base which is 10 minus 3 plus 9. So it is plus 6 nanometer. That's it. You've converted. Okay. Let us work out another one example. 65 picometer to millimeter. 65 picometer to millimeter. I want to convert picometer to millimeter. Can you please try at your end? .65 picometer to millimeter. If you want this tabular column, I will show you. I'm not expecting the right answer. You just please try at your end and please come up with any answer. We'll correct it. If it is wrong, we'll correct it.
64 into 10 power minus 9.
Okay, 10 power minus 9. We'll check Abhinav.
Yes, ma'am.
Shall we do it together? Sriniti? You have any answer, Kanna?
Yes, ma'am. 65 into 10 power minus 9.
Okay. Your answer is matching with Abhinav's answer. Okay. Patel?
65 into 10 power minus 6.
Okay, minus 6. What is your name?
Fawaz.
Fawaz. Okay, it is 10 power minus 6. Okay, your answer is quite different from Abhinav's and Sriniti's answer. We'll check. Fine, we'll do it together now. So first step is I have 65 picometer. What is the value of pico? It is 10 power minus 12. That's it. Now I want to convert this picometer to millimeter. So I'm going to write the unit and I'm going to write the quantity of milli in the denominator. The quantity of milli is 10 power minus 3. Now I'm going to bring this term to the numerator. So 65 into 10 power minus 12 into 10 power plus 3 millimeter. So I have common base which is 10 minus 12 plus 3 which is minus 9 millimeter. Fine. Abhinav's answer and Sriniv's answer was right. Fawaz, I think you made mistake here, I think. Right?
Yes, ma'am.
Fine. Okay, that was a good try, Kana. Okay, we'll work out another one problem. I have 500 milliliter. I want you to convert into liter, that's it. Milliliter to liter, that's it. Last problem, milliliter to liter.
0.5 liter.
Okay. Rakshan's answer is 0.5 liter. Right. So 500. And what is the value of milli? It is 10 power minus 3 liter. So 500 is nothing but 5 into 10 power 2 into 10 power minus 3. So I have common base 5 into 10 power 2 and minus 3. So it is minus 1 liter. So 5 into 10 power minus 1 liter or 0.5 liter. Is that clear? Rakshan's answer was right. Do you have any doubt?
No, ma'am.
So in this session, what are all the things we have learned? We have learned what is matter, what is atom, molecule, why atom has to get converted into molecule. We understood what is stability, element, compound, chemical bond, valency, what is chemistry, and finally unit conversions. right? And we understood, we have learned what are all the subatomic particles, their masses and their charges, right? Do you have any doubt?
No, ma'am.
Okay. Sir,
Yeah, we can,
session
yeah.
wind up
Yeah,
பண்ணிக்கலாமா
we
sir?
can close, madam.
Okay, okay sir, okay.
Thank you, madam.